My first name's Elmer. Just get that out of the way. So I don't go by that, though.
Did you say Warner?
Elmer.
Oh, nice.
Man.
Yeah. So since my middle initial is P, I'm Elmer P. If my last name was Lee, I guess I'd have it made. But probably not.
Hey everyone, we're in the height of a release season and we've got some good news to share. If you remember back on episode 109 entitled Retail Price Wars, we talked about stores charging 3, 4, or even 5 times the MSRP prices on their allocated bourbons. I've been told that Sazerac actually caught wind of this episode and has actually decided to do something about it and treat those stores who are pricing their products fairly. They're getting increased allocations and even shots at more barrel picks. Needless to say, this is a win in the bourbon community. So if you're one of those good retailers out there, reach out to your state reps for Sazerac and talk to them about it and see what they can do for you. The next bit of business is that we have done our Patreon giveaway for October, and this month's winner is Travis Roden, who takes home a bottle of Buffalo Trace single barrel store pick that was done in partnership by the Wine Rack, Harvest Restaurant, and yours truly of Bourbon Pursuit. This barrel completely sold out in less than 48 hours, so perhaps that's an indication of something. If you want to be a part of the next drawing, make sure you go and support the show on Patreon. That's patreon.com/Bourbon Pursuit and sign up for a donation level that helps support the show but also gets you entered into the drawing. With that, enjoy this week's episode.
Ed Bly and Rising Tide Spirits are back again with a new release of Old Stubborn Bourbon. And this release of Old Stubborn is a premium hand marriage of 10, 11, and 12-year cask strength, barely filtered pot still bourbon. It comes in at a staggering 123.8 proof, and the flavoring grain for this one, which the last one was wheated, but this time it's now rye. Rich, sweet, and bold with a long finish that's sure to be another eye-opener. You can order online at Sealbox or thebourbonconcierge.com, and you can even purchase in person at Revival Vintage Spirits, and even now with very few select stores in Kentucky. You can get it now while you can, but be sure to do it because it's not going to last long. From their bar to yours, Chad and Sarah of the popular YouTube channel It's Bourbon Night bring you their favorite at-home old-fashioned mix with the new Elemental Elixir's Golden Hour Syrup. It's a custom-made syrup with notes of bold black tea, warm spices, and orange zest. All you need is your favorite whiskey and ice. No bitters needed. One bottle makes 16 drinks, so that's only $1 a cocktail before you add your own whiskey. They can also be enjoyed in other cocktails or spirits, mocktails, coffee, tea, and anything you can think of. It's crafted locally in Lexington, Kentucky, and you can get your bottle now at whiskeyambitions.com. Do you ever pour yourself a bourbon, swirl it around, and then start struggling to come up with tasting notes? And perhaps you're also looking for a good Father's Day gift idea. Well, you can now solve both with a kit from Knows Your Bourbon. And unlike other nosing kits on the market, Knows Your Bourbon kits feature real ingredients for the most authentic aromas. You can smell real Tahitian vanilla bean instead of some synthetic aroma that's just made from chemicals. So head on over to knowsyourbourbon.com and enter code BP10 for 10% off your order. Always find what you love at Total Wine & More. With so many great bottles to choose from at the lowest price, it's easy to find your favorite Cabernet or a new single barrel bourbon to try with some help from one of their friendly guides. And with every bottle comes the confidence of knowing you just found something amazing. With the lowest prices for over 30 years, find what you love and love what you find only at Total Wine & More. Curbside pickup and delivery available in most areas. Visit TotalWine.com to learn more. Spirits not sold in Virginia and North Carolina. Drink responsibly and be 21.
Play Whiskey Wednesday Round 11, the memory game. Until June 26, each week you could win one of our 12 incredible grand prizes. Select 2 doors at checkout, and if they match on drawing night, you'll win that bottle. Not a match? No worries. You still score a Weller 12-year. Every $5 ticket gives you 5 chances to win, including 4 weekly bonus prizes. Get your tickets now at give270.org. Charitable Gaming License ORG 0002703.
So welcome back to an episode of the Bourbon Pursuit Podcast, the official podcast of bourbon. This is I'm here with Ryan today, and Kenny here as well as usual. And this is going to be a subject that Ryan and I were discussing before we started recording here, and I mean we're definitely kind of I'm green to this. We were going through this, and you saw some terms.
You're sugarcoating it. We're idiots on this. Yeah, yeast is one of those things. Like some people like hype it up. Four Roses is like, oh, our yeast, and some people like brag about it. Some are just like, we get yeast from like everybody else. So I really don't understand what yeast does, and I'm interested to kind of. I know the basics of it, but I'm really interested to see how impact it has on the bourbon we drink.
Yeah, I mean, we know yeast is part of the process, but we don't know much about it, right? I mean, you can talk to some other people, like when we interviewed. Actually, you weren't there for that when we interviewed at Heaven Hill, and it wasn't Denny, but it was Charlie from Everyone's Bourbon Experience, and said that the one thing that they saved during the fire, Heaven Hill fire of '96, was that they had to go grab that bucket of yeast, because it's like, this thing that's been around for generations, all this other kind of stuff. However, like, it's still kind of a mystery about what all this really means, right? Of all that sort of stuff. So today we brought on not only somebody that knows a lot about yeast, but he is a doctor of yeast, right? So I think that's PhD of yeast, right? So today we have Dr. Pat Heist. Dr. Pat Heist is we didn't actually get his title before there, but he is a lead at Firm Solutions, as well as the Wilderness Trail Distillery. So Pat, welcome to the show.
Thank you very much.
So I guess before I screw up anymore, like, what's your official title? What do you go by?
Well, I'm co-owner here. Shane Baker and I own both Firm Solutions and Wilderness Trail Distillery, but I'm also the chief scientific officer. So I, take the lead on a lot of R&D roles. We do a lot of product development around yeast and bacterial contamination and just overall process optimization in distillery. So not only are we looking at things like flavor, but we're also looking at things like helping distilleries to maximize the amount of alcohol that they can make per bushel of grain. So we do a lot of different things for a lot of different distilleries.
All right. So, yeah, I mean, that was one thing, because we kind of did a little bit of our research before we started this. And the real reason why we had Pat on is because I saw at the New Orleans Bourbon Festival, Pat gave a deep dive into yeast. And I said, that's a great subject for this podcast, and I want this information to live on. And he actually was able to, send over some of the slides that he presented. And I saw that you do a lot of things for, like you said, over like 5,000 distilleries is kind of what you guys are up to now.
Well, 500 distilleries, yeah.
Oh, so I gave you a little bit of.
When Kenny says research, he literally just pulled open the laptop and scrolled through the.
Soon to be 5,000, but currently only 500. So.
Well, you're on the road. You're on the road to 5,000. We'll put it that way.
Yeah, baby steps.
So before we get into a lot of this stuff about the yeast and the fermentation, the cooking, distillation, all that sort of process. Talk about like your history in bourbon. Like, where did you come along and get enthralled with it? Or was it just something that when you were at UK and going through your studies, you said, oh, okay, well, I like drinking, I like doing this. It kind of
love yeast.
It all comes together.
I want to do something.
Yeah. Well, I've always liked to drink. That was probably the beginning of it all. But in college, my background and my interest really lied in microbiology. So studying, bacteria and yeast and viruses and parasites and, fungi, all kinds of different microorganisms. And I had a very crooked path getting into distilling, because I actually, as I was talking to you guys earlier, my graduate degrees are in plant pathology. So I did a lot of work with farmers on diseases of field crops, which everybody knows, there's grain crops involved with bourbon production. So it's actually a very big part of what we do. My first real job out of college was a medical microbiology professor at the medical school in Pikeville College. So I went from plant science, plant microbiology, to human microbiology. And so the next logical step after that was pretty much to get into distilled spirits production. Seemed kind of logical. And over in Pikeville, that's where I lived for a few years after when I was at the medical school. And, there's a lot of emphasis on moonshine, and there's a lot of, old school moonshine producers over there. And I guess, kind of along with my interest in microbiology, that whole lore of moonshine production, and obviously Kentucky bourbon production is, in everyone's blood who lives and is raised here in Kentucky. So I started consulting for some companies that marketed yeast to distilleries and ended up doing some consulting. And then Shane and I formed Firm Solutions in 2006. And again, we market yeast to distilleries. We provide technical support. And one thing about being a yeast provider is that the yeast pretty much gets the blame for every problem that you could possibly have at it. So,
You're the scapegoat.
You could have bad grain and it manifests itself in fermentation. Hey, why isn't this yeast working? So if you're going to get the blame for every problem, eventually you got to figure out how to solve other problems besides yeast issues. And so that's kind of what led to us, being the company that get the phone calls for other distilleries when they have issues. And so, that was kind of the nemesis of getting into yeast. And then once we had a successful business in Firm Solutions, we had the financial backing to build a distillery. And so, and plus it was a very logical move for us. We do a lot of training for, different organizations as well as different distilleries. And so having our own distillery kind of allowed us to bump our training game up quite a bit, because we can actually have people here at our facility teaching about all this hardcore science while we're showing them how to run a process. So that's kind of a little bit of an intro.
Yeah, it's kind of like in the grass business, a lot of factors like the weather and stuff. It's not exactly our fault, but it's our problem. We have to deal with it. So I know exactly where you're coming from.
So I guess another question I have about just the Firm Solution business in general. I mean, we were kind of talking when we were leading up to this. We talked about, what yeast means in regards of like Heaven Hill. It's been around for 200 years, or Maker's Mark, and all these very long established companies. But like, we know that the craft whiskey business is booming, and it's not like they just like went in their backyard and found a strain of yeast and said like, here we go, like we're in business, right? So I mean, that's where you all step in, right?
Yeah, exactly. Yeah, we help people understand. So, if you're looking for a particular type of yeast, I mean, we have our personal collection. We've got over 6,000 different yeast strains that we've collected from not only distilleries all over the world, but also from various environmental surfaces, fruits and vegetables. And I mean, we find interesting yeast all the time. Just, looking around in our normal environment. I mean, you don't have to go much further than a fruit stand to find 10 different yeast strains. It's just a matter of deciding which ones are going to contribute positively to the flavor profile, depending on what kind of spirit you're making. And also, they need to have a certain amount of vigor to where they can finish off sugar and make a certain amount of alcohol. So,
No, I was going to say, this is fascinating to me. It kind of reminds me of like a weed dispensary or something. You have like all these different kinds of strands of marijuana and like give you different effects. And like with yeast, it's like, I didn't fully understand there's that many strains of yeast that you can literally go pick out what profile you're looking at from the different strands.
Yeah. Well, yeast have different smells and they're also very sticky. So it kind of relates a little bit.
So pretty similar.
I don't know if I try smoking yeast, but
I'm sure we've done crazier things though, right?
Yeah.
So, before we dive down more into like the fermentation of the yeast, I'm kind of looking at the presentation where we're talking about just like the factors that go to influencing the bourbon and stuff like that. So I kind of want to start right there because you talk about like grain quality as something that goes into it. And we know that there's a lot of craft distillers and they try to do this farm to glass stuff. We know some of the big boys out there, they just say, we're going to buy, like say Wild Turkey, all they want is non-GMO. You look at some other big boys and they all source from the same places, and maybe that is in Germany or maybe that's in somewhere else because they can get it at a higher volume at a lower cost or something like that. So talk about some of the grain quality and what that does, into a bourbon mash bill.
Well, I think, grain quality, obviously, just like if you go to the farmer's market and you're looking at, a head of lettuce, you're going to pick out the rotten one or you're going to pick out the nice green one. I mean, some of it's a common sense,
Right.
but there's also, in addition to quality of the grain, and normally when we talk about quality, we're talking about things like starch content, moisture content, whether or not it's got any type of evidence of a fungal manifestation or insect damage, or if it's broken, or, I mean, there's a lot of problems you can have with grain. Does it have a bunch of pesticides sprayed on it? Does it have a lot of foreign material in it? If it's half corn cobs in there, that's not good quality grain, because you're not going to make a lot of ethanol out of corn cobs. So there's a lot of factors relative to the quality of the grain, but also just looking at the diversity of different grains. I mean, think about how many different varieties of corn there are. I mean, yellow corn, there's blue corn, red corn, white corn. There's all these different heirloom varieties. And I think, these craft distilleries, and, we're in this situation too, where, this is our distillery. We can do whatever we want, and we do things like we want to do it, and we make things that we like to drink. And so I like to see a lot of this creativity that's going on with different grains. So not only grain quality, but just the diversity of choices of different grains. I mean, we work currently with one farmer here in Boyle County. It's Cavendale Farms. They grow our corn and our wheat, and we're able to work with them and actually zero in on very specific varieties. Whereas if you're just buying grain on the open market, it might be from multiple regions, and it might be multiple varieties.
So I guess one of my questions is like, I guess you could say like it is an exciting time for experimentation, because somebody could be messing around with red corn or like the blue corn, but typically it's yellow or white corn is like the majority of what goes into it. I mean, when we think about this, like, does the color have a factor in the outcome of the bourbon? I mean, it's still usually clear when it comes out, but I mean, is there a huge difference in the flavor profile too? Because I'm not too sure if I'm sold there.
There are differences. I wouldn't say huge differences, but there definitely are differences. Now, from a business standpoint, if you're purchasing grain that you're getting, a maximum of 60 to 90 bushels an acre, compared to a grain that you're getting 200 bushels an acre, there's economics involved. You can get a bushel of corn for $3 or $4, whereas, red corn we've seen for as high as $56 a bushel. So, I was talking bushels a minute ago. I don't know if I said pounds, but, about $3 or $4 a bushel for yellow corn, and, up to $50 or $56 a bushel for red corn. So there's, economic decisions to be made as well. I mean, you can make the best product in the world, but it's got to be economical.
And I mean, do you think some of that is like a marketing hype to it too, to say like, oh, we only use red corn? Like, is it more of a marketing angle? Because from the way you're making it sound, like from an economics at scale, it doesn't make like the biggest sense to go with something that is outside the norm, right?
Well, when you talk about making distilled spirits, I mean, there's a good bit of profit in it organically compared to, for example, we also work with fuel alcohol distilleries. For every gallon of 200 proof alcohol they sell, they've got to make a profit at about $1.50 to $1.80 a gallon. We're paying as distilleries upwards of $23 per that same gallon just in federal taxes. Yeah. So it's a completely different scale. So there is a little more leeway on spending money to make it. But to your point about, is it really make that big of a difference? I guess we'll see, because there's really not too many products that have aged long enough to really see what they're all about.
Absolutely.
I'm excited though about it.
So I guess another thing that you want to talk about that you brought up was like the pesticide stuff. We know that Wild Turkey is a very big like non-GMO kind of producer. So when we think about just pesticides in general, like is that just more or less I guess you could say something that the distiller wants that he or she sticks by and says like, that's just like the line that I draw? Does that have
clause?
Yeah, because I mean, does it really have any adverse effects? Or I mean, is that something that we're not going to know for years from now, right?
I just know it. Well,
Yeah,
from like
well,
Roundup
first of
Ready
all-
corn, it's much more profitable to use stuff like that and cheaper than having organically grown corn. It's it just makes much
Well,
more financial sense.
Yeah, exactly. And when somebody says something is organic, it's easy to say it, but is it really?
Right.
And then there's that whole debate, and we'll set that to the side. But in terms of pesticides, I mean, obviously, a lot of the pesticides that are used on foods are food quality pesticides. However, there are situations where, and again, nobody is intentionally trying to get anything with pesticides or any other type of compromised grains. And these days, they grow a lot of varieties that are naturally pest resistant rather than spraying pesticides. It's just something you got to watch for. And, this time of year, when you have, you got people trying to clean out their bins to make space for the new harvest. Sometimes you get into kind of some garbage on the bottom that, whether it's pesticides or it's just low in starch or whatever the issue is, you can see issues from time to time. And that's where we employ this lab I got behind me, and look at things like nitrogen content or, there's a lot of different things.
What is the most common pesticides used, I guess, in corn? I would assume herbicides for weeds, but is it insecticides or fungicides?
Well, you familiar with BT corn? I mean, that's
Oh, yeah.
a pesticide that's formed within the plant. I don't really know
Bacillus thuringiensis, is that what you mean, or whatever?
What's that?
Bacillus thuringiensis or whatever. I think that I'm trying to remember the term from college days.
Bacillus thuringiensis. That's right. BT.
Yeah, that's right.
That's what, it produces a toxin that protects against certain boring insects.
Right.
But yeah. I don't know
Does that all get so would that all just get distilled out when it gets converted into the alcohol?
Well, it's arguable because what pesticide are you talking about? Is it volatile at all? Is it heat stable? Is it heat labile? Is it going to be destroyed in the presence of heat? So there's just a lot of considerations. I mean, we don't normally worry about things like pesticides just because it's rare that we're going to have a significant amount of pesticides on our grain.
Right. Well, hell, I don't care. I just got done spraying Roundup right before I came over here.
So I guess, is there any time that you could figure out before you get into like mashing or distilling that there's a problem with any of the grains that you are sourcing? Like, is there any red flags that you're supposed to be looking for?
Yeah, like I mentioned before, we're certainly looking for moisture content. Last time I checked the Chicago Board of Trade price on a bushel of water, it was a lot cheaper than a bushel of grain. So if you're buying high moisture grain, you're just paying money for water. Same thing if it's got foreign material in it. If it's got corn cobs or rocks or other things, you're paying money for a bunch of garbage. So those are some things that we look at before, as a truck pulls up, we're going to be doing moisture content. We are looking at starch content, and then we're looking at, does it have any garbage in there that we need to be concerned about? So those are just a few of the things. Then we can get deeper into fungal mycotoxins, which was one of the things I mentioned in the New Orleans talk. It's a rare occurrence, but it does happen from time to time. We just actually had some rye that we sent off for mycotoxin testing because we were a little suspicious due to some discoloration that we saw. It ended up not being a concern, but, that was kind of an example of something that we had to, we noticed something and we followed up on that observation with, some testing.
So what's the, we gave a lot of love to corn right there. Is there anything that's special about either wheat or rye or barley or anything like that?
Well, first of all, if you look at Kentucky bourbon production, there's not a lot of rye grown in Kentucky. So there is a good bit of wheat and corn. So all the corn and all the wheat that we use here at our distillery is produced locally. The rye, they are looking to grow it here, but there's just not been a big demand for it. My understanding is that, here in Kentucky, if you have a better chance of getting off with some rye or with wheat, rather, if you double crop rye in there with it, you can have rye volunteering in your wheat. So that's one issue. And the weather conditions.
Yeah, our weather's not very conducive for rye.
Yeah. But we're a Kentucky proud operation. We try to get all Kentucky grains if we can. But, most distilleries are buying rye from out of the state just because most of the really good rye is grown, in the upper Midwest.
It's a finicky grass. It needs to be babied. It needs a nice, cool northern low humidity climate.
Yep, and there's a lot of pathogens that take it out, and a lot of moisture here that causes issues. So the barley, that's something else. There's not much barley grown in Kentucky either. So the vast majority of malted barley that's used in the state of Kentucky is not grown in Kentucky. So those are the little nuances about some of the other grains.
So get technical on me on when when corn as a starch turns into sugar, which makes alcohol. Like, what's some of the actual technical aspects of that and what makes that happen?
Well, okay, so you start with the grain. That grain is milled, to increase the surface area. So you take whole grains, you grind them up into flour, and that exposed starch. I mean, if you think of starch like a string of beads, for example, and each bead on that string is a glucose or a sugar subunit. And so the enzymes that are present in the malted grains, malted means the grains were germinated. There's enzymes present there, or some distilleries will add commercial enzymes. But those enzymes will take that starch or that string of beads and just cut it up into little pieces, eventually resulting in the individual beads, which are glucose molecules. And that's what the yeast needs to take up and produce alcohol. So it's essentially a digestion that's occurring.
Okay, so I guess, okay, go ahead. Sorry to interrupt.
No, the yeast really can't use starch. It's too complex. It's got to be broken down into its individual sugar subunits. And so that's done by enzymes that are present either in the malted grains or in enzymes that are supplemented.
So at this point, are we in the mash or the cooking stage at this point then?
Yep. So that would be the cooking stage, is where you're blending those milled grains in with hot water. And the heat of the water also is important because the enzymes that convert starch to fermentable sugars are the most active at temperatures above, let's say, above 150 degrees Fahrenheit and even up in the 185, 190 Fahrenheit range. So a lot of people think, well, I'm destroying my enzymes with that heat. If you get up above boiling, that would be the case. But, like at our distillery, we normally don't cook any higher than 192 Fahrenheit, strictly because we're trying to preserve the activity of those enzymes. But that's where the starch conversion is.
That when it go into the mash cooker and it's bubbling?
Well, that would be, so the mash cooker is where you're applying high heat and you're adding your grains. So in our distillery, we're adding our corn at about 190, our wheat or rye, depending on what kind of recipe we're making, we're adding that somewhere in the 155 range. And then our malted barley goes in around 150 to 145 because that's got the enzymes. It needs to be, treated with a little less heat.
I think you're thinking of more or less maybe the fermentation stage, right? Yeah. Where it's bubbling. Yeah. But so there is like a cooking stage. I remember because we took a tour one time and then they open it up and there's these things that are just spinning everywhere and mash is just flying. Yeah, it was super, super hot too, right? So so you're adding different grains at different temperatures and times during the mash, I guess, cooking process or whatever.
Yes. Yeah, and then that's cooled, and then that's moved over to the fermenter. That's where the yeast is added, and that's where you get that consumption of sugar, production of alcohol, and you also get a lot of carbon dioxide being given off, which is what provides the bubbling in fermentation.
I know we've asked this question before, but it's good to always reiterate, getting, always in front of people. But what's the difference, or what's the definition of a sour mash versus I don't know what they call sweet mash too. So what is the difference? Because you can see it in the labels. However, not everybody knows exactly what it means.
Yep. So sour mash, it's kind of like if you're making sourdough bread. You take a little bit of the culture that your grandma gave you and you mix it in with your bread. And then that's kind of provides in some respects, it's contamination and other, maybe a pH reduction that leads to a certain kind of a flavor. And so in sour mash whiskey or bourbon production, you are basically, so we talked a minute ago about combining milled grains with hot water in the cooking process, right? So in the sour mash process, you're taking part of your water that you're using on the front end is going to be the leftover byproduct from a previous distillation. It's called stillage. So you have, when a fermentation is finished, that's called beer. That beer goes into the still, the alcohol is removed, and then the remaining, grain and water and other contents, that is collectively referred to as stillage. That stillage is also called backset, and because it's sent back to the front, and that's what sour mash is. So at our facility, we do what's called a sweet mash. We don't incorporate any leftovers from a previous distillation. We're starting with all fresh water. And so there's reasons why you would do that or why you wouldn't do that.
Well, what are those?
You guys want to say? It was like fetus baby.
Don't leave us hanging.
Yeah, really.
Well, heck, I had to wait for you to ask, man. You're
like, I'm being interviewed, right?
That's right. A couple reasons why you would want to run. Most of the very large distilleries do sour mash process. So one thing, if you think about energy consumption, you're blending all this water and you got to heat all this water. Well, if I've got stillage coming off of my still, that's 150 plus degrees. That's a lot of temperature savings or energy savings that I'm going to get if I use that as part of my water. The other thing is that distilleries have to get rid of that stillage. Farmers come to our distillery and take it away by the truckload. And some distilleries are in kind of a bind about, even after our next expansion, we're going to be producing about 250,000 gallons of stillage every week. So we got to get rid of that stuff. It's a major factor in a business model of running a distillery. So if we can incorporate a great deal of that back into our process, then that would be less stillage we'd have to get rid of. So those are some business reasons why you would want to do a sour mash. Some scientific reasons might include pH reduction. So you have all the organic acids that were produced in that previous fermentation. And if you donate those into a new batch of mash, you're getting the benefit of a reduction in pH. And what that helps with, at least in theory, is that it limits the amount of bacterial contamination. And that kind of leads us into the other part of, what makes a sour mash. It's the sourness of, maybe some of those organic acids that were produced by the bacteria in a previous fermentation.
It's the funk left over.
Yep. It actually, think about sour beer production. I don't know if you guys have had much of the sour beers they're producing these days, but there's some really interesting flavors. And that's an example where you can take some of these contaminating organisms that are contributing to that funkiness of the distillate, and you're tasting what they grow like kind of in their more natural state. And chemically, if you look at what's going on in the barrel, we know that organic acids condense with alcohols to form esters. Anybody that knows anything about bourbon has probably heard of the family of chemicals called esters, which contribute significantly to a lot of the fruity or other notes that you get in bourbon. So those organic acids that are produced by bacteria very likely are, forming esters during barrel maturation.
Man alive, I'm getting schooled over here. This is crazy. So at this point, we're into fermentation right now. So that's kind of where I want to move next, right? Because this is kind of where you get to shine, right? Because during the fermentation, when it moves over to the fermentation tank, is when you add whatever one of the 6,000 strains of yeast that you have, right? If you're anything like me, then you can't get enough about bourbon. And that's why I'm a subscriber to Bourbon Plus magazine. Bourbon Plus is a quarterly publication that tells the stories from the heart of bourbon, the farmers who grow the grain,
the distillers who labor over the process, and the people like you and me who raise their glasses to celebrate it all. Subscribe to Bourbon Plus magazine today at bourbonplus.com, that's PLUS.com, and use code PURSUIT at checkout for $5 off your subscription. Shopify's already taken the cash register online, helping millions sell billions around the world. But did you know that Shopify can do the same thing at your retail store? Give your point of sale system a serious upgrade with Shopify. Shopify's point of sale is your command center for your retail store. From accepting payments to managing inventory, Shopify has everything you need to sell in person. And with Shopify, you get a powerhouse selling partner that effortlessly unites your in-person and online sales into one source of truth. Track every sale across your business in one place and know exactly what's in stock. Connect with customers in-line and online. Shopify helps you drive store traffic with plug-and-play tools built for marketing campaigns, from TikTok to Instagram and beyond. And get hardware that fits your business. Take payments by smartphone. Transform your tablet into a point-of-sale system, or use Shopify's point-of-sale Go mobile device for a battle-tested solution. Plus, Shopify's award-winning 24/7 help is there to support your success every step of the way. Do retail right with Shopify. Sign up for a $1 per month trial period at shopify.com/bourbon, all lowercase, and go to shopify.com/bourbon to take your retail business to the next level today. Shopify.com/bourbon.
During the fermentation, when it moves over to the fermentation tank, is when you add whatever one of the 6,000 strains of yeast that you have, right? So I kind of want to talk, first, what's going on in there? Like, how is yeast contributing to it? Get as technically as you want. Then I kind of want to talk about a little bit about flavor profiles of it as well.
Okay. So in the fermentation tank, you've got those, you've got that very sugar-rich mash that you've just made in the cooking or mashing process, and you're adding yeast. So it's cooled down to a nice temperature of around 85 degrees Fahrenheit on average. Some distilleries start a little higher, some go a little lower. You add the yeast. The yeast, again, this is a microorganism. It's a living organism that is going to consume those sugars, and it is going to produce alcohol and other flavor components. Again, we've got esters, there's aldehydes, there's a lot of different things. There's also breakdown products of the grain. As those sugars are being metabolized, there are other chemicals that are liberated that may or may not end up in the distillate. So that process, if you look in terms of yeast populations, we're probably maxing out at somewhere around 150 to 200 million yeast cells per milliliter of fermentation mash. So if you consider, the end of your finger, about that much, about every this much mash, you have about 150 million yeast cells in there, converting those sugars into alcohol. That process takes about 2 to 5 days, depending on what temperature, what yeast strain, what type of grains you're fermenting, and other factors. And, after that point, you have hopefully depleted the sugar, and you have the maximum amount of alcohol. I mean, that's the name of the game here, is make as much alcohol as you can. If we're making a beer, we might want to leave a little bit of that sugar behind, because you're actually drinking the end result of fermentation. Here, our end product is going to be the distillate that we take off of that.
Mm-hmm. How do you prevent contamination? Because, yeast is like all over the place, right?
Yep. Well, first of all, you are starting with an abnormally huge population of the yeast that you intentionally put in there. Okay. So it's like I said, if you've got 150 million cells per milliliter, and you have a random piece of dust falling in there every now and then, it would take a very strong organism to outcompete.
We're talking like a dead body at this point is what you have to really have to contaminate it or something.
Yeah. Now, we've seen some squirrels stuck in recirculation lines at distilleries before, so you don't want to rule that out. But there's really no way to completely prevent bacterial contamination.
I guess that you got so much of that one variety of yeast, it's going to outcompete any yeast that would happen to get in there.
Well, that's the idea. However, if you don't keep your fermenters clean, or you have a situation where you're piping. I mean, you can imagine how, so if I'm cooking in one tank to make my mash, I'm cooling that down, and then I'm sending it through a set of pipes over to another tank where I'm going to do my fermentations. You know, how clean is all that stuff? If I'm sending it through a dirty pipe, I might pick up a whole bunch of bacteria before I've even added the yeast. So those are some examples of how you can get bacteria in there. Most distilleries here in Kentucky that produce beverage alcohol are using open top fermenters. So things can get in there, you know, bugs possibly could land. And again, it just comes back to distillery sanitation, you know, keeping a very, you know, if you got flies buzzing all over the place, you know, they'll get into your mash. So you want to, you know, keep a very sanitary environment. You want to keep insect populations controlled and all that kind of stuff. But those are some ways that bacteria can get in. Once they're in there, they're growing. You know, a yeast reproduces about once every hour and a half to 2 hours. A bacterium reproduces every 15 to 20 minutes. So very quickly, the bacteria can build up to problematic populations. Now, very interestingly, you know, this is a topic very dear to us because it's one of our primary areas of business, is helping distilleries control bacterial contamination, as well as understand what type of bacteria that they have that might be positively contributing to their flavor profiles. So, you know, the good news about the bacteria that contaminate distilleries, and again, we've been studying this for over 10 years, and we've got a collection of over 15,000 different bacteria that we've collected from distilleries all over the world. And one thing that's very interesting is those bacteria are largely the same ones that are being sold in probiotic supplements now. You know, all these different probiotics and kombucha.
About the microflora in your gut.
Yeah, absolutely. Well, all these organisms we've been collecting for the last 10 years and kind of treating as the bad guys in distillation or in fermentation. Now we're in the nutraceuticals business.
So here's a question I get, like when I'm battling diseases in grass or whatever, you know, I apply fungicides, but, you know, there are a lot of, like you said, a lot of beneficial bacteria and fungi doing things to, you know, help the grass with mycorrhiza or whatever. But how do you, I guess, target the specific bacteria that are causing harm versus just wiping out all the bacteria?
Well, you would have to in a very controlled manner, add in the ones you want, if that's your goal. There's very few facilities nowadays that are purposely adding bacteria, or I guess rather purposely adding specific bacteria. There are ways, like if you maybe do a short cook on your mash, you can leave more contaminating organisms that were in the grain alive. And so you kind of allowing some contamination to grow. You know, there's some different tricks that can be done if you actually want to allow organisms to grow. However, you know, as experts that study this, for every 100 bacteria that we find that would likely contribute favorably to the flavor, there's going to be a few that we don't really want in there. You know, I don't know about you guys, but I don't want the causative agent of bloody diarrhea in infants to be part of my flavor profile in bourbon. So, you know, I had to say that. But, you know, that'd be an example of the kind of organism we don't want in there, you know. But apart from flavor considerations, really, I think one of the bigger worries of bacterial contamination is that we're reducing our yield. We're not making as much alcohol as we could be making. I mean, in a real serious bacterial contamination situation, you can lose up to half your alcohol. And if that happens fermenter after fermenter, you know, hey, I'm supposed to make 150 barrels a day and I'm only making 70. I got a problem here. Somebody's got a big problem here. And then you take that up to a fuel alcohol facility. I mean, some of our customers have fermenters that are over 900,000 gallons apiece. So how much do you think they're losing when they get 50% yield reduction? It's millions of dollars a day. So luckily for them.
So they call you.
Yep, absolutely. Yep. So and good for them is a lot of times it's kind of like if you've drove a crappy car for long enough, you know every little sound and what it is. And so a lot of times we can hear the scenario and very quickly respond, sometimes on the phone, you know. sometimes you almost hear the phone drop of them running to do what you told them to do, you know.
So I kind of want to talk a little bit more about the yeast strains here in themselves, right? So you have over 6,000 that are Firm Solutions, but how many of those can actually be used, like say in bourbon production, right? You know, you were talking about, you know, ethanol and fuel production and stuff like that. But when we're talking about bourbon production, we're talking about flavor and stuff like that. Like, how many can actually be used? Are we narrowed down to like a baker's dozen here or something, or what?
Well, we currently market about 9 of those strains and use about 9 of those strains in our process. We have good information on hundreds of those strains. And then there are several thousand of those strains that we have yet to characterize. I mean, it takes a lot of, we have to do a lot of DNA fingerprinting and genome sequencing and, you know, actually get into the DNA forensic level when you isolate a yeast and you see it under the microscope and you know, hey, that's a yeast. Well, you don't know if it's a Saccharomyces cerevisiae or a Cluveromyces or a Piscia species. I mean, there's a lot of different ones. And then, so if it's a Saccharomyces cerevisiae, which is the common yeast used in beer, wine, and distilled spirits, is it going to be one that, again, can utilize sugars and make as much alcohol as I need, as well as have a favorable flavor profile? So there's a lot of questions.
So Henrik asked a question, true or false? I've heard that yeast contributes about 15% of the flavor profile to a final bourbon.
Man, that's a tough debate to get involved with, really, because there's all these percentages flying around.
You probably say 100%, right? You're selling yeast.
I would say that's probably fairly close estimate, but it's really hard. Because the yeast is making all the alcohol. So if the alcohol flavor is, how much is that in the flavor? So it's kind of hard to pinpoint, but I would say, somewhere around there.
He asked one more question. He said, when you look at some of these fermenters, like towards the end, there's like this thick layer on top. It's almost like you could scoop it with a cup and like it's like a sponge cake almost. And then some other ones, there's not. Is this actually dependent upon the type of yeast that's in there?
Well, probably not so much the type of yeast as to the amount of grain per amount of water. So, for example, when we're running our pot still, we run what's considered to be a higher gravity mash. That means we have more grain and less water. So out of that mash, we're going to get a higher percentage of alcohol. And in that case, if you've got more grains in there, there's more of a chance that those grains are going to be pushed to the top during a very vigorous stage of fermentation and form that cap on the top. Whenever we're running our column still, we're having to rely on that mash to flow down through our column. And so we have to set that at a lower gravity. So it's got more water in it. And in those cases, we don't often see a cap. But again, it just depends. We just ran some fermenters or that had some heirloom red corn in them. And it almost looked like you could have walked across the top of it. I'm sure you couldn't have, but it looked as if you could. It was like a barren desert on top. It's all cracked.
Like granola bar.
I was going to say, Jesus walked on mash bills here. Yeah. So, you kind of almost walked in the next piece. You talked about low gravity, and then there's something else that you were talking about earlier called like high gravity. Like, what's the difference in what that means in regards of like how big a fermenter is? Like, is that really what it means or what?
No, it's okay. So if I'm making 100 gallons of mash, I'm going to use X amount of corn. Okay. And that's going to put me at a certain gravity. Well, if I add more corn, that's going to increase my gravity, but I still got the same volume. I would add less water and more grain, you see? So that's really what gravity is about. And again, the grain is what contains the sugar that equates to alcohol. So the more grain that I put in there, eventually if you keep putting grain in there, you're not even going to be able to stir it anymore. It's going to be back to dry again. But, you have a happy balance between something that I can agitate in a tank, something that I can pump through pipes, and also something that the yeast is going to be able to use all the sugar. So, whether you're talking about bricks or balling or gravity or Plato, there's a lot of different, scientific ways that we can estimate sugar. We actually use a piece of equipment here in the lab called a high performance liquid chromatography. And so if on one hand, we get a very simple gravity reading, but with the HPLC, we can see, well, how much glucose do I have? How much maltose? How much maltotriose? Are my dextrins being converted into fermentable sugars? Am I producing organic acids? There's a lot of questions you can answer with this one test on this one very sophisticated piece of equipment.
It's already over my head, so I'm not even going to try to attempt to ask a question about any one of those. If it's over like 8 letters, like I'm probably not going to understand it anyway. So there was another good question here by Michael Urato. He says, is it because of bacteria? But what is the cause of, say, like a mutated yeast? He says he's read about that say Jim Rutledge discovered it. It was used at the Four Roses gift shop for like a 17-year release at one time, as well as the 2012 and 2013 limited edition single barrel offerings. So what actually factors into that?
Well, I mean, that is a very complicated subject. And if you look at how does diversity occur over time with any type of, whether it be humans or yeast, it's through mutations that arise. And, a mutation, let's say that you run a very high temperature fermentation, and you have mutants in there that are more able to grow at higher temperatures. So maybe what you started with becomes diminished, and those heat tolerant mutants sort of take over because you are constantly selecting for those heat tolerant mutants. Or it could be any other one of them, could be low pH or acidic conditions would select for a particular type of organism. So with the yeast, where you really got to, like where we sell yeast, we market what's called active dried yeast. So we're going back to a master culture whenever we're making that yeast. And so we're kind of going back to the original culture. If we are, if we're fermenting here at our distillery and then we're saving a little bit of that inoculum for the next batch, and then we're just kind of going through time, that's where you can get yeast mutating. And again, it's just such a complicated area. You can have many, many things. Some of those things would be detrimental. Some of them maybe not so detrimental.
Okay, so I've got one more. Maybe it's like a folklore question, because I did a tour at Castle and Key, and I was there with Mary Ann and a few other people, and they were saying, we're trying to figure out like how can we replicate everything that was done here at Castle and Key, and they were saying that they were looking at old fermenters and they were going through old pipes and they were trying to scrape everything. And they're like,
get Q-tips.
Well, and they really did. And they're like, I think we found like a piece of yeast. And so they tried to go and like find the closest possible yeast strain they could to try and replicate what they were doing at Old Taylor at that time. Now, is that something that you really think is possible, or is it just something it's a good marketing ploy at this point?
Yeah, absolutely. we've actually we do a good bit of forensic work for different distilleries. So, for example, we had a situation. We had a distillery that brought us an old yeast jug it was actually in the museum, the whiskey museum over in Bardstown. And this particular family retrieved their jug, brought it over here to us. We attempted to culture something out of it, which you can imagine after 100+ years, there's not going to be much alive in there. But we were able to retrieve some residues that allowed us to extract DNA, and we performed like a DNA fingerprinting exercise, and we were able to match the DNA from that dead strain in that yeast jug to a strain that we have in our collection. So we were able to essentially revive that yeast that had been used in their family distillery through some forensic DNA level technology.
Interesting. I mean, we both said it, but I mean, that really is.
So the distillery really can't say they're using non-GMO, because it sounds like you can GMO a yeast, strains.
No, that's not GMO. Again, what we did is we basically got the fingerprint of it, and then we just matched it up to an existing natural strain.
But you're cloning in, like duplicating it, right? I mean,
you're
not changing the genetics of it, I guess.
Yeah. All we did is we just looked into the DNA and we said, okay, this is what that strain looks like, and then we found that same person in our collection. Gotcha. So we didn't have to. Now we do a good bit of genetic modification in yeasts for the fuel alcohol business. I was mentioning to you, these fuel alcohol plants, they're not using any malted grains. So they're actually purchasing commercial enzymes. And so one of the big projects that we have going on here in our lab is to engineer our fuel alcohol yeast strain with a glucoamylase enzyme that would provide millions of dollars of value for each distillery that we do business with.
Interesting.
Per year.
Are you taking investors?
Well, maybe.
So, we're gonna try to speed this up a little bit. So I kind of want to talk about, right here as we talked a lot about like what could happen to the yeast during the fermentation. We talked about the changes that had happened. Now you're at the process of actually monitoring it. So like when you're monitoring during a fermentation process and you're monitoring what the yeast does, like what are you actually looking for during this process?
Okay, so several things. One thing that we're monitoring is temperature of the fermentation. I mean, the yeast, as they consume that sugar and produce alcohol, they're giving off a lot of heat. So we have to keep that temperature down. So we're monitoring that. We're also regulating, cooling water or whatever we got to do to get that temperature to be maintained. We don't want to go over 95 Fahrenheit, for example, in fermentation.
And that's where the coils come in too, right?
Yep, that's right. And so the other thing we want to monitor, as I mentioned earlier, we want to check the yeast populations. So at any given time, what is my population of yeast? Like I said, a good healthy fermenter should have around 150 to 200 million cells per milliliter. The other thing I want to look at, it's important to know how many yeast I have, but how many of them are alive. So if I've got 200 million cells per milliliter, but they're all dead, that's not going to do me a whole lot of good. So we have certain types of stains that we use and this is all done microscopically. So yeast counts, yeast viability. We're also looking at budding. Yeast reproduces by a process called budding, and so we can actually see that under the microscope, and we wanted to record what is the percentage of budding. So we're looking for a budding percentage somewhere around 20%, for example. Outside of microscopic analysis, we're also doing, again, the HPLC, high performance liquid chromatography. And there's where we're looking at sugar consumption. So again, at the end of when I send that beer to my still, I want to have used up all that sugar. So day by day, we're taking HPLC readings. Look, am I making the same amount of alcohol? Am I utilizing my sugar? We also get a reading on organic acids like lactic acid and acetic acid. Lactic acid is not produced by yeast. It's produced by bacteria. So when we see that, we know that's an indicator of bacterial contamination. And when those levels get to be a certain amount, that's where we'll kick in additional, okay, now we need to culture out of there and get those bacteria. 4 years from now, if we have a batch that's really super good, we want to be able to go back in time and say, well, they had these very specific contaminants in there. And maybe to recreate that, we have to incorporate those contaminants.
So at what point do you get too scientific, whereas it's...
Well, I think we got to that point a long time ago.
I was going to say, he's a doctor. I think the scientific method is what he lives by, right? So
that's right. Yep.
But it's like, the distillers back in the day, they didn't have all this. I mean, maybe they had some of it, but
not to the level
of the technology you have now. And
yeah. Oh, absolutely. Yeah. What temperature are you at? Oh, it's boiling.
Yeah, exactly.
Oh man. So this is awesome, by the way. Like this is so much good information that we're getting out of here. And I'm looking at some of the other slides that you had sent. And the only other things that are kind of standing out for me that I'm not entirely sure of, like when you say like gram positive bacteria and gram negative bacteria, like what does that mean? And then is that something that is just an anecdote to this, or does this have something also to do with the bourbon production? Like kind of explain that.
Yeah. So bacteria, there's a staining method called the gram stain that divides bacteria into two major groups, gram positive and gram negative. And those differences are largely based on their cell wall and cell membrane characteristics. So most of the time, what we see in fermentation are gram positive bacteria like lactobacillus, pediococcus, Weissella, enterococcus. There's a whole bunch of different ones. Lactobacillus is probably the most prevalent. And then there's a lot of different species of each one of those different genera. So those would be what we would consider to be kind of normal bacteria. I mean, we find them on grains, they're in water. I mean, it's no wonder why they're in there. And those are the ones, again, those are the same bacteria that you find, that you're eating in yogurt and that, you know, that people actually like. Gram negatives have a subset of bacteria that kind of fit into that category, like Acetobacter and Gluconobacter, which are sort of grouped in with the lactic acid bacterium. Acetobacter is historically been used to produce vinegar. Acetic acid and vinegar are the same thing, so Acetobacter. So again, that's a gram negative that you'll see in there. But there are some other gram negatives, like I mentioned, the causative agent of bloody diarrhea in infants. You know, that's another example of a gram negative that just by the thought of it, you know, I don't want that in my dang bourbon. But, you know, and plus they could be pathogenic. So if I've got a facility and I'm running, you know, 10 100,000 gallon fermenters, and I've got, you know, 10 to the 7th population of a pathogenic organism in there, and I don't even know whether I do or not, you know, that could potentially be an issue. Now that's a very rare thing, but it's something that we feel is important to monitor, not only from a flavor aspect, but you know, from a yield aspect and just knowing about your process.
What's the side effect of saying like putting a wild yeast into a bourbon mash bill?
Well, it could give a very desirable flavor, but it could steal away most of the sugar and make other byproducts besides alcohol. Just really
and by the way, we also need to define for me, because I am not smart here. Like, what would you categorize like as a wild yeast besides me just going outside and scraping some dirt and, you know, finding something rather than going through your
lightning bug jar out?
Yeah. Rather than like going to your catalog and, you know, getting a bag of it. Right.
Yeah. Well, here's the thing. If you take a yeast and you intentionally put it into there, I wouldn't consider that a wild yeast. I mean, if you know whatever your intention, right? Put in there, it's kind of like being non-wild. Things that aren't in there are wild, or things that you didn't intentionally put in there would be wild yeast. So you could even have a strain of Saccharomyces cerevisiae that is a perfectly good bourbon producer that makes its way into your process, and that if you have the ability to separate it out from the yeast that you intentionally put in there, that could be considered a wild yeast. So at very general level, that's what a wild yeast is, just something you didn't intentionally put in there.
It's like a weed. It's just something that's undesirable.
Yeah. Well, in most cases, it's going to be undesirable. But in some cases, it can actually have a good effect. And there are some distilleries that try to get contamination. I was just at a distillery a couple weeks ago, and I mean, you talking about some funk going on in that fermenter. I mean, I could see this film over the top of it, and I even kind of called out, "Hey, man, that looks like a piscia species." And he's like, "Yeah, it probably is."
You see that?
Oh yeah, I've got plenty of those. I don't need any more of those. But those are useful for. Have you ever heard of kefir? Like dairy kefir and water kefir. It's kind of like kombucha tea. It's one of these fermented beverages that people are drinking and going crazy for.
Kombucha, but not kefir.
Yep, kefir.
I've had kava tea.
What's that?
Kava. Have you ever had kava tea?
Is it kind of like kombucha?
Yeah, kind of, sort of.
Okay. I've had a lot of those things because again, we're in that business now because we're trying to utilize our collection here.
Right.
I mean, this was fantastic. I'm honestly out of questions when it comes to like the yeast side of things. Like this was, by far one of the most informative episodes that we've done in a while, just in regards of just something that seems so, I don't know. It is molecular. It's not necessarily minute because you can see it, you're adding it to it, but it does have a huge impact on what's actually happening here during the process, right?
Yeah, it's very cool. I enjoyed it because I know just a little bit enough to be dangerous. It kind of relates a little bit to the horticulture and plant side. It is living organisms, so it kind of is relatable. But I could nerd out with you for a little while.
I've got like two more questions, I think. So at what point is the yeast like out of this? Like it's out of the equation. Is it like during the distillation, after the distillation, once it's in the barrel? Like when is the yeast like stop playing a role?
Well, essentially, once the sugar has been depleted in the fermenter, the yeast are going to, at least to some degree, survive until you send them to their death in the still. So they've just got done working very hard for you, consuming all those sugars, making all that alcohol, and then you basically send them to the death chamber. So that's essentially.
So do they essentially like overwinter, or like, I guess like, a fungi overwinters until it's basically the temperature and moisture, the environment's conducive for it to be active again? Does it create like fruiting bodies or?
Yeah, I mean, yeast have complex life cycles. The part of the life cycle that we're seeing in fermented alcohol, beverage production is the asexual phase of the organism, but it actually does undergo sexual reproduction and hyphal production in other more complex stages of its life cycle that we don't see in a fermentation environment. So as out in the wild, as these yeast are, maybe they're living on the surface of a peach, and then that peach rots, and then that organism overwinters and then makes its way, reproduces. And I mean, there's a whole complex bunch of factors about how yeast survive in the environment, but they undergo other phases of their life cycle in the environment that allows them to overwinter and to survive and to maintain a certain amount of diversity, through mutations and, sexual reproduction is where, you're getting two different strains coming together.
Gotcha.
And then another thing, because, I consume a fair amount of beers as well, right? We all have our, collection of, nice and, high-end beers and stuff like that. But there's been on probably I can count on at least two hands how many times I've had beers that have been recalled because of, they say something went wrong, the enzymes, it's soured, it's funk now. Like, does yeast play a big part of that and towards the beer process? Because, I mean, I know that I've got one sitting in my fridge right now. It's been recalled, and I've tried it, and I'm like, yeah, this kind of tastes horrible now. But where does the yeast play in that? Because as we had mentioned before, when you're doing a bourbon mash, you're dumping a lot of yeast in there because you want to get as much alcohol out of it as you can. However, when you're doing a beer, you're probably not doing as much yeast. So is when you're pushing this through and you're not necessarily killing it off by putting it to the through the still, it's still alive and well and kicking in the beer. And so is that a big reason why it does go sour or go bad?
Well, yeah, I mean, if you look at how beer is produced, and, again, we offer beer strains as well. We don't discriminate just distilleries. We also have beer and wine strains, and we do a lot of work for beer and wine producers. But, if you think about beer production, you are removing the solid material prior to fermentation. So you're fermenting in what's called a clear mash. Okay, so the yeast will actually settle out to the bottom in beer production, and you'll reuse those. So you can imagine that if I'm reusing something, there's a potential for contamination to build up in that, depending on how many times that I reuse it. And so beer producers will often have a set number of times that they're going to be able to reuse that yeast before they'll start totally from scratch with fresh yeast. So in beer production, you would have a little bit more propensity for contamination, but beer producers typically see a beer producer fermenting in open top vessel, for example. So there's just a lot less, I guess, you just don't want to get contamination in a beer unless you're intentionally trying to make a sour beer.
Yeah,
recycling the yeast definitely contributes to that in beer production.
Gotcha. So to kind of round this out, we had one question that was from Ben Jackson that kind of relates to our very questions at the beginning about corn. When you are sourcing grains, is it better to get it at, how old should they be to like get as much hydration out of there? 3 months, 6 months, a year, whatever it is.
To get as much hydration.
Well, you said you want a low concentrate of water in it, right?
Yeah.
So like
how long do you want it to be
fresh?
aged in the silo or whatever?
Well, here's the thing. So whenever they bring it out of the field, it might be in the upper teens, like 18, 19, 20% moisture. And then they'll dry it using certain types of air drying technology. Typically, like here at our distillery, we'll reject grain that's 16% or higher moisture. We're targeting about a 14% moisture. And again, it could be harvested this week and be brought to our distillery next week at 14% moisture. So it's really not a matter of sitting around. I mean, with some grains, there are physiological changes that are occurring in that grain even after it has been detached from its mother plant. And those changes can, if you're familiar with seed dormancy, what types of physiological development does a seedling have to undergo before that seed is capable of germination? There are chemical reactions that are occurring over time that we know, like in wheat and rye, for example, that can contribute to foaming. So whenever we are getting fresh wheat, we're going to be on the lookout for fermenters that are foaming, or same with rye. So that's an example of where you would actually prefer a grain that has been harvested for a few months as opposed to, corn. I mean, it's got enough oil in it that itself is a natural anti-foaming agent. So we can use fresh corn and it not have any problems. But with wheat and rye, there are considerations relative to foaming and how long that material has been harvested for.
But here in Kentucky, I mean, you're only getting fresh corn, a few months out of the year?
Yeah, but it stays pretty good. I mean, we've had great corn all the way up until just recently, and it's still pretty good. I mean, we're just seeing some, maybe a little more trash in it and some other things.
Some worms wiggling around.
I'll tell you what, Ryan, I don't know if we're going to have a doctor on again because I feel like an idiot after a while. Actually, I don't know. I mean, you were keeping up pace over here. You were
somewhat. I remember some of these terms.
You were just spouting out like steroids and all those other kind of things. I don't even.
My dad would be proud. He spent all that money on my education. I can keep up with the PhD.
Well, Pat, I want to say thank you again for coming on the show today. I want you to give one more plug for Firm Solutions and Wilderness Trail while you're at it.
Yeah, absolutely. Any distillers out there need any help or anything distillery related, that's what Firm Solutions is all about. And, Wilderness Trail Distillery, we're actually coming up on our oldest bourbon is going to be 4 years old next month. So in 2018, we'll be releasing our first bourbon, which we actually made it and we actually aged it. And so the stuff we're going to have in our bottles is actually our stuff, and it'll be bottled in bond. And, we're shooting for a 7+ year, but, at this point, we got to at least trickle out a few bottles at 4 years.
Well, if you practice what you preach, I'm sure it's pretty damn good.
Oh, yeah, it's super good. Not bad anything, but it is delicious.
Well, Dr. Heist and, Pat, Elmer, whatever you want to go by, thank you so much for being on the show today.
That was awesome.
It was fantastic. And, thank you for everybody that was joining in on Patreon and the live chat and asking some of those questions. It was definitely good to have some of those things in there. So if you want to be a part of this next time, support us on Patreon, and you can sit here and you can watch the live chat and you can watch this interview as it happens.
The doctor's brain.
Yeah, exactly.
And
right.
If you have any funk going on your, fermenters or whatever, you call Pat.
Yeah, you know who to call now. That's for sure. So yeah, that was awesome. So with that, we'll kind of wrap it up here. So if you like the show, make sure you follow us on Facebook, Instagram, and Twitter. We're going to be pushing out new stuff every single week. If you want to also help support the show, we've got a Patreon campaign, patreon.com. I should really stop drinking during these shows, right?
Yeah.
It's .com/bourbon pursuit. Then you can sign up for different donation levels to help support the show. We've got t-shirts and all kinds of cool stuff that are going to be on there. With that, Ryan, close us out, man.
Yeah, and if you have any show suggestions, feedback, comments, we love hearing from you guys. We want to know what you guys want to hear, so just let us know, and we'll see you next time.